Okay, so that's why we are having this kit here. Imagine if you are having a set of particles. Ladies, please, I need your full attention because now I'll explain a concept, an important concept. So, imagine that you are having a series of particles connected to each other. Okay? Two-dimensionally. We'll try to make it two-dimensionally. Well, I think we need to have it Bob 3D in terms of the columns that we will be having here. Okay? So, if you recall, this like that, this is a hinge because it can rotate. Now, I'll make it a fixation like that, like that. Okay? Type. So, in terms of having this situation and having these balls above, okay? So, what do I have here now? Down here is a fixation, and up is what? Ladies, what's here? يعني okay, it's a rudder because يعني now it's not connected, but actually we are talking, if we are talking about this point like that and this point like that connected to each other, as if it's an intermediate hinge, صح? It's a point that doesn't transfer moments. That's the most important thing you need to get out from here. That here, this connection does not transfer moment. And put 15 lines beneath this word. حلو؟ طب how it will affect us? Let's look now at a scenario. Suppose I have a member like this, and a member like this. Okay? Well, let me pick two big ones. A member like this, another one like this. Okay? And they are connected here, like that. Can you see it? Does this point transfer moments?
No.
False. Do you agree? Everybody agrees here? So actually, in terms of our structure, this point together with that point and that point and these members together, they do something called, or they make together a structure that we call a truss. Now we will see what you can see here. This is something very common in North America. And if you Google wooden truss, you'll get a figure of as if you are having a cross section in the house, in the roof of a house. And you will see this. Okay? مش بس كمان لا ده كمان maybe you will see what vertical members here can be connected here. Okay? طيب, what makes this different than a beam or a column or whatever? This connection, and this connection, and this connection. A truss, by definition, the connections between the members are not rigid. They are simple connections. Okay? They are simple connections. So, if we go back to the concept of the particle equilibrium, what do we have? A particle connected to another particle, connected to a third particle, and so on. You agree? Ladies and gentlemen, you agree? Everything is good? Fine. So, if we use this concept, we are talking about particle equilibrium per joint. We'll call each particle a joint. So per joint, I'll have what? Two equations. صح? Two relationships. Sigma fx equals 0 and sigma fy equals 0. Do you agree؟ أهي. طيب خلوا بالكم ده ايه per joint. هو اصلا for the structure as a whole, for the whole structure as a rigid body كله على بعض, the truss as a whole, we had what? برضه 3 equations. Sigma F equals 0, sigma F x equals 0, sigma Fy equals 0, and sigma moment equals 0. That when studying this structure as a whole, this is actually what we did in the last tutorial, and this is what we did in the last 2 lectures. صح? To get the reactions. Do you agree? طيب. But if I have for n number of joints, how many equations will I have?
1 for each.
So I'll have 2n equations.
Wow.
Do you agree? معايا? You get it? In addition to these 3. In addition to these 3. طيب. Let's go into the lecture itself now. So this is what I was talking about, which is the point that you are having the joints are simple joints. Again, we have some terminology. I don't know whether the camera can show it or not. Let's try the camera. So we have some terminology here in trusses in general. The horizontal members, or حتى even if they are slanted, the upper and lower members, they are called the chord members. So the upper members are called the upper chords, lower members are called the lower chords. The vertical members are called verticals. These slanted members are called diagonals. This is the simple thing. And again, we said that to idealize the joint, we deal with each joint as if it's a particle, and we are dealing with particle equilibrium here. Okay? So, typically, for a typical truss, because a typical truss wants to bend like this way. So what's down, we are having, as if you are having within this truss a couple of tension and compression. What's down is under tension and what's up is under compression. So typically the lower chord is under tension and the upper chord is under compression. This is a classical example, and actually which is very similar to this one. That typically the most common thing you will find trusses in are bridges, even pedestrian bridges, the ones that you see while crossing the Mehar Mushir, for example, crossing whatever most of the main streets now in Cairo, they have these pedestrian bridges, and most of them they are trusses actually. Okay, if you go back and look at them. But now the question is, there is another issue of stability. Again, when we discussed previously stability, we said we are having 2 types of instability. Remember, talking about structures globally. We're having 2 types of instability. One type is what we call the instability due to having number of equations versus number of unknowns. We compare them. So how can this be translated here? How? We discuss stability. When it comes to the calculating reactions. Stability of the structure as a whole. Right? We said that if you have the number of equations is more than the number of unknowns, that means that there is a missing reaction. So that means that the structure is unstable. This is one type of instability. And another type of instability that we said that maybe I could have a situation where the number of equations and the number of is unsatisfying the number of unknowns, but there is one direction that is free to rotate, or one direction that is free to move. So we call this geometric instability. Same thing applies here. So, for example, if I remove this member, what will happen? Will fall. So this is a geometric instability. Okay, تمام. So that means that in one case maybe I could be missing a diagonal member, like here. This case is unstable, so it's free to translate like this. Okay. Thus it's free to move like a parallelogram. Okay, like a pendulum. Okay. However, something like this is stable. Okay? This is this one. This is why I made this one with you. Okay, so here we are talking, and by the way, I mean one of the another name for trusses is pin jointed frames, because as if they are frames, however, they are connected with pins, not rigidly connected. Okay, right. So you could have different types of trusses. I'll not go into that detail. We didn't solve a truss, we got a reaction.
No, الكلاس كان truss بس يعني we didn't solve it.
You got the reactions for the classroom. Not we didn't solve the truss. What we'll be doing is that we'll be getting the force within each and every member of this truss. طيب, let me ask a question concerning this truss. Ladies. خلاص we know it خلاص symmetric دي خلاص ماركة مسجلة بتاعتي. Okay. So and I like symmetric structures in general, so maybe that's why I like to get them. So other than that, and who hates symmetry? Anyways, so the point here is what? My question to you. This structure, is it statically determined or indeterminate? Is it stable or unstable? Look at it. Say stable.
لا عشان تقريبا عشان هي rigid وفي الفام ده
You know what that's similar to?
ملهاش support يعني قصدي مفيش مش زي يعني مفيش أي حاجة free to rotate كلهم fixed يعني مش عارفة أشرح
These are two hinges down there. Okay. طيب. Let's go into one step and another, and then give you my analogy. In terms of numbers, how many reactions do I have?
3 main reactions reactions عند كل
How many reactions in the support reactions? 2 per side.
2
per support.
per hinge.
So it's 4 in total.
اه.
So can I calculate using these 3 equations? Sigma x equals 0, sigma y equals 0, sigma y equals 0.
Why not?
You are having an additional reaction.
بس ما أصل هو
سيجما اف اكس يعني اف اكس بتاعت دي ودي
حاضر مع بعض.
اف واي بتاعت
مع
دي
بعض.
ودي
Together.
اه
Okay. Looking at the whole structure as a rigid body,
ماشي برضه.
can I easily calculate the 4th reaction?
ايه الفويس؟
We are having 2 here and 2 here. Okay? So you're having 2 in y, 2 in x. Okay? And you are having 3 equations. Sigma x equals 0, sigma y equals 0, sigma y equals 0.
هو ايه الأنون؟ كل الرياكشن
الأربعة
The 4 are unknowns.
مش عارفة
I cannot do it unless there is something that can help me. Okay? طيب. We said that what is our additional equation to get a reaction? To get the additional reaction, كنا بنسميها ايه conditional equation, you remember? Which happens when I have what? Something starts with an I. Intermediate hinge. Intermediate hinge, okay? طيب. Can you see an intermediate hinge here? This thing. Bravo. Because this point is free to rotate.
ازاي بقى؟
Look at it.
هي
عشان هي 1 point
حاضر.
والاثنين التانيين في point فوق وتحت فوق وتحت فهي مثلا
Look at something else. Imagine something else. Imagine a reverse situation. Imagine having a member here. Would this be free to rotate?
لا
ما ينفعش. So what's happening here is what?
ماشي
What's happening here, physically speaking, that we are missing one member,
it's not really
but we got an additional reaction. So if I had if I had this member there and that was a roller and that's a hinge, it would be what? Statically determinant and stable كل حاجة. If I remove this reaction and I have this as a roller, keep this member, keep it not there. Remove this member. It's not there. I'm keeping it absent. And this is a roller. What will happen? Unstable. However, I'm having this situation that I'm removing this and I'm having this as a hinge. Does that remind you of something? Our ballerina, does that remind you of something? Does that remind you of something? Subhanallah, we were created stable. Aho. This intermediate hinge is my hip joint. This, the intermediate hinge, is my hip joint. These supports are my feet. And God created friction to protect us. So if the ground was frictionless, somebody, if you are walking and there's soap on the ground, okay, whatever, ceramic, whatever, you slip. Why do you slip? Because of this, there is no friction. So this friction makes the horizontal reactions. Okay, so yes, these are my legs. This is the truss, which is my legs, and this is the hip joint, which is the intermediate hinge. Okay, this is how we live, and this is how we move. It's not like this. Everything will be broken. It will be instability. Okay. طيب. So again, we said that these members will only carry axial forces, tension and compression. How will we calculate it? Today we'll cover what we call the method of joints. Okay, method of joints is simply that I'll start calculating per joint the joint equilibrium. Sigma fx equals 0, sigma fy equals 0. Okay, classically in most of cases, خلي بالكم اللي أنا بقوله, in most of cases, not always, we'll start with the reactions first. Okay, then we'll move joint by joint and we'll get the forces per members. Okay, so when will I have instability here? If I'm missing a reaction, okay, and I'm missing a member, or I'm missing a member, or both together. Okay, if I'm having less members, as the one without a diagonal, so less members, less unknowns. So we have fewer unknowns than the equations. Okay, fine. Then let's move on. So here you have a recipe. نتحرك ازاي بقى? Start with what? And then we'll start with the method of joints. Hi, جماعة. First step, we draw the free body diagram for each joint. Sigma of x equals 0, y equals 0. Then you start joint by joint. Moving on. And which joint will I start with? ابتدي بمين؟ Remember that there was a song by عبد الحليم حافظ. You don't know it from maybe your parents know it. نبتدي منين الحكاية؟ Okay? So نبتدي منين الحكاية؟
اللي هي الجوينت مع الهنجز.
Specifically about this truss, by the way, any joint can work. يعني أصلا specifically here. Why? Because here most of the joints are connected to only two members. But this truss is an easy one. It's not a case that's in which the truss has a joint that has three members connected to it. We will see this. We'll see cases. Okay. But other than this, here in this case in specific, I can actually start from joint B without getting the reactions of. So joint equilibrium on joint B, I'll draw a joint out. I draw the joint and draw the forces coming out of the joint. And by the way, and I'll draw the force on the joint. So this is the 500 Newton. This angle, so this is 2 meters, 2 meters, so this angle is 45 degrees. This, I'll call it TBC or FBC, force on member BC, and this is force on BA. I'll solve two equations to get them. Okay, so in this case in specific, I start without doing the reactions.
عندي سؤال، لو احنا هنا هنجيب y component و x component ل FBC.
So you will start excellent. قولي لي انت بقى تبتدي بمين فيهم؟ So I here I'll do both. I'll do sigma fx equals 0, sigma fy equals 0. Which direction shall I start with? In terms of the number of unknowns.
X. FX.
fx, why fx?
We
عشان
have
في
the
عندنا
500.
واحد نون.
Bravo. So you ladies, you don't need me يعني ما شاء الله شاطرين. Okay. خلاص. I think this one will be better إن شاء الله. Wow. Okay. So here I'll start by sigma fx equals 0 equals. I'll get the horizontal component of FBC. صح? So this is FBC. Oh, it's 45. It doesn't make a difference whether it's sine or cosine, but it's صح classically. This is 45. So it's cosine 45 plus 500. This is equal to 0. Therefore, FBC is equal to negative 500 over cosine 45. And this is actually negative 500 root 2. Okay? And negative here means what? And that's very important. We always start.
هو احنا ليه عاملين بس لا ليه في اكس مفيش مثلا اي اكس؟
Yes. What do you mean by AX?
احنا بنعمل
We are talking about.
مش
خلي بالكم. This is joint B.
يعني we're taking
عند
only
point B بس.
طب احنا لازم ناخد
الحاجات
اه
اللي
ليه
طالعه
احنا
من
دي
point
بس؟
B بس. ما تنسوش بتشوف.
هناخد اخوات والله we'll take the left. We will continue.
لا قصدي دي مش قطعة على وجه الابيض.
حاضر.
ما بقول لك هيبقى اكتر من ايه.
Ladies, ladies, ladies.
ايوه ليه بقى؟
حاضر. I'll answer the question. When you take the whole thing, the whole structure, we are talking about the big rigid body. All these forces are internal forces with respect to this rigid body. But they are not unknowns. What's unknown is what? The reactions. You can take the whole rigid body to get the reactions. But then I'm not getting the reaction. I started with what? I started with that free joint. In other cases, I start with the reaction. Depending on the case by case thing. Depending on what's faster to be done. Okay? Fine. This is just an example, ladies. This is just an example. Okay? Fine. We got this number, so after that we back substitute that in sigma Fy equals 0. It's very important to mention something. Classically, we start by assuming that all forces are tension forces. Tension force is coming out of the point like this, as if I'm pulling the point. However, the compression, the arrow will be coming into the point. Until you prove that it's a compression. Till you prove it's a compression, but دي حاجة تانية. Okay? Then, يعني هنا مثلا I'll back substitute in this thing with the sign. So a negative sign means it's a compression. A positive sign means it's a tension. Okay? Because that's your initial assumption. Alright? But sigma Fy equals 0. So here I have negative FBA minus minus. I'm substituting this value with its direction. 500 root 2 times sine 45.
طب دكتور حضرتك كنت بتقول النيجاتيف معناها ايه وبعدين ما كملناش.
So negative here means what? It's a compression.
ماشي. compression على point B.
Yes. It's compression. It's a compression. The member is under compression. It will be compression here at B and at C. Okay? Right. Then, therefore, FBA is equal to, well, send it the other side, and this is negative, negative is positive, it's equal to 500. Right. Then, if I look at joint C, we got what? We got FBC. I substitute it in joint C. I hope this is joint C. This is the FBC that I got. خلوا بالكم بقى, ladies. If I draw it like that, that means it's a tension. But I knew that it's a compression. يقوموا عاملين ايه؟ You have one of two options after knowing that it's a compression. Either place it as like this but with a negative sign, or just have it like that. Because it's coming, pushing the joint. It's a compression. Okay? It's pressing on the joint. Okay? Right. This is 500 root 2, and this is F AC or CA, call it whatever. And here also I have a reaction YC. Do I need it? I'm gonna get this force. صح? And this angle is 45 degrees. I'll simply I don't need this thing. So this is sigma Fx equals 0 equals negative FAC plus 500 root 2 cosine 45. Therefore, FAC is equal to 500. This is what we call the method of joints. Why did they call it? Why did they name it method of joints? Because we are moving joint by joint, one by one, one by one. Okay? Amen? I like to give an example of or give an analogy. The method of joints is what we call, it's like an open cut surgery. يعني as if somebody made an open cut surgery, فتح بطن. Okay? Thus, there's what the I don't know the English name for this thing. There is المنظار اللي هو when you have a opening and they remove one thing like that. Okay? So I think this was an instability in this direction. يعني to make this thing stable, صح بقى كمان بيعملوا ايه؟ بيحطوا حاجة اسمها bracing to connect the two perpendicular things. See? Now this thing is braced. This what happened now will not happen again. Okay. Right. So this is how this guy. That's another example now. So that's another example. But برضه here he starts from برضه the joint that's the cantilever joint, the one that's at the end. Let me get the screen. So here he starts برضه from the one that's at the end. Okay? And he's moving on inwards towards these guys. Amen? In a lot of cases, you will be in a situation that you have to get the reactions first so as to start from the joint that has the reaction. Yani in the previous example, or in this example, somebody could go get the reactions at A and at C, and then start from joint A or joint C. Okay? So somebody will ask me a very nice question. So which joint shall I start from? It's only you who will answer this question when you solve a lot. Classically speaking, my advice, start with the fastest one. Start with the one that will give you the least number of unknowns, okay, to get, and so on. Okay? Right. What about this lady? Start with this, which one? A. Okay. Well, طبعا he did the reactions for us. I mean, he did the reactions for us. Okay? So he already did the reactions for us. He got the 24 clips down, 22 clips that way, and then 24 clips on the other one. Oh, he did the reactions here. He did the reactions here. So, okay, it's done for us. But classically, this will not be the case in an exam or in a quiz or in your assignment even. You will have the problem and you will get the reactions, and then you will start by doing the thing. Right. What do you think is happening at joint B? You know what?
It's just a transmission on. It's a rigid connection.
No, it's not a rigid connection. No, we said that all the connections here are not rigid. There is no connection that's transferring a moment. Okay? But let's look at joint B. And I want to say something about joint B. Okay? Let's look at joint B. This one. So if I have, let me redraw this truss there in order to be able to solve it easily. If I have this thing like that, that's here like that. Okay, and it has a lateral load of 22 kips. Okay, and this is B, C, D, that's A. He did the calculation for direction and he said, okay, this is 24, that's 24, and this is 22. Okay? So, you notice something when you look at joint B. First, there's no load, صح? At joint B. There is no load. تمام? What else? Trying to zoom in so that everything will get better. So what else other than having no forces? If there's no forces, you're having two forces acting on the same line here. Okay? So if I draw joint B out on its own, I'm having FBC. Exactly opposite to it is FBA or AB, call it whatever. And coming at an angle, whatever the angle can be, I'm having FBD. So, give a guess. What would be the force in FBD?
Equal to
Okay. What would?
يعني what will be
Will it be a compression or a tension? Will there be a force from the first place? Let's imagine
Tension?
something.
Tension?
Let's imagine something. We agreed that Cartesian coordinates are something relative that we have made up. So there's nothing in the space that's an x and a y, horizontal and vertical. Okay? They made it horizontal and vertical because it's easier, because the vertical is against the gravity, so to make it gravity, so we deal with the vertical axis. But imagine local axes here. A local x-axis like this, and a local y-axis like this. Local x and local y. Okay? That's local x and that's local y. That's why I do it in red to make it different. Right? If we look at these local axes and we look at the y-axis, we'll see it. You know what? One piece of wisdom I learned in life. In a lot of cases, and you as architects will feel it, you just need to look at things from different angles. You just look at it from this angle. What will I have in sigma Fy? It's equal to 0. كده كده صح؟
يبقى FBD equals to
So actually the FBD cosine
equal
of
to
whatever angle, let's call it, let's
Equal
say,
0.
yeah, let's say, is equal to 0. Therefore FBD is equal to 0. This is what we call a zero member. This is what we call a zero member. And I adore them. بجيبهم كتير. Okay? So I could get you a trust has a lot of members. And you guys will, hey, what's that? هنحل كل ده. But half of them are zeros.
طب ايه لازم دي؟
Why is the zero member there? Because maybe it's there for two purposes maybe. First, to increase the strength of this very long member. So I'm increasing its capacity. I'm increasing its stability. I'm reducing its buckling length. You will know, we'll take this when you go to the coming course, inshallah, design course, and you'll take the steel. So you'll know that buckling is very sensitive to the length of the member. So if you divide the length of the member by half, you divide it by 2, you are actually quadrupling the strength of this member. Okay? So this is one thing. The other thing, because maybe in this case, yes, in this load case, it's doing nothing, yes. But suppose that this load moved and it's here. Now this member will not be a zero member anymore. So zero members have several functions. These are two of them. تمام؟ طيب. So again, which one shall we start with? يعني now we knew that this is a zero member. خلاص كده أنا هنا أقوم جاي هنا. But by the way, in a lot of things, a lot of cases, it's much easier to write the forces on the diagram for you guys to relate. You have your truss drawn, write the forces on it. This is 0 F minus 0. Okay, and so on. We'll start solving it. We'll get the different forces and we'll solve. Okay? And طبعا we know that this one is equal to that one. خلاص. They're equal. But once I solve one of them, I'll get the other. طيب. What's a here? This angle. This is a 3, 4, 5 triangle. 3, 4, 5. Okay. So the height is 3, and so this is 3, 4. So if this is angle theta, so tan theta equals 4 over 3, sine theta equals 4 over 5, cosine theta equals 3 over 5. صح? So if I start from joint A, and then row, I have the 22, I have the 24, I have this FAD, and I have FBA, at an angle of theta with the vertical, and this is the properties of the theta. So should I start with the vertical or horizontal direction? Should I start with sigma fx equals 0 or sigma fy equals 0? Fy. To get rid of this thing, then the x I'll get rid of that. So sigma fy equals 0. It's equal to what? FBA sine or cosine theta? Cosine. So FBA cosine theta minus the 24. Do you agree? Okay? By the way, ladies, please, in each and every joint, you need to draw me the free body of the particle of this joint. Okay? We said this is a particle equilibrium, each one is a particle on its own. Okay? Fine. So this is actually 3 over 5. Therefore, FBA is equal to what? 24 over 0.6. So this is 30, 32. Okay? 32. 3 over 5. 3 over 5. So the 5 will go up. And the 3 is down. 5 times up. This is 40. 40k. Okay? This is a 40k. Right? So, Bardo, again, you always write it on. So this is 40K. And look, it's a positive, so that's a tension. Okay, that's a tension. Yeah? Then sigma fx equals 0 equals, I'll have the FAD plus a component of this force, which is plus 40 sine theta back, which is what? 4 over 5 minus 22, the reaction. Therefore, FAD, I'll send everything the other way. So this will be at 22 minus 32. So this is a negative 10K. Okay? So this is a compression, negative 10 in most of the cases. Maybe you noticed here. Within the same joint, you will find a tension member and a compression member. It's super rare to find all of them as tension or all of them as compression. Okay? But then you notice once I wrote that stuff here, I can write this as 40K column. I know it's equal. I don't need to write it again. Once you have the stuff on the free body diagram, a lot. Everything is right. Okay? Then I can go where? D. Oh. Let's go at joint D. Joint D. What's happening at joint D? This is a zero member. I'm having a 10K like this. This is 10. I'm having the 24. And I'm having FDC at an angle that I call it alpha. What's the story of alpha? Ladies, look here. Again, alpha is one of the very famous triangles. Very famous triangle. There is another famous triangle. 5, 12, 13. You know this one? The 5, 12, 13 triangle. Okay? So, and this angle is alpha. So actually, tan alpha is what? 12 over 5. Sine alpha is what? 12 over 13. So sine alpha is what? 5 over 13. Ladies, do you agree? You have something to discuss with us? Okay. So, here, look here. Look here. I'm having one and one. And there are two directions. So actually, as a check, you can do both. And you should reach the same results. Okay? Anybody? Yeah, you're having here, you can do sigma fx equals 0 and get FDC. And go and check it in the y. If you get the same result in the y, that means that everything is right. Okay? So, sigma fx equals 0 equals FDC cosine of sine alpha beep beep. Ladies, cosine of sine alpha. Cosine of sine alpha. Cosine alpha. Which is what? 5 over 13. Okay? Plus 10. This is equal to 0. Therefore, FBC is equal to negative 10 divided by 5 over 13. So this would be negative 26K. You want to check it? But I don't trust myself. Okay? So, I'll do the other direction. Let me erase the 0 1. I'll do the other direction. check. Check. Sigma Fy equals 0 equals, please look here please, 24 plus FBC sine alpha. What sine alpha? 12 over 13. Therefore, FBC is negative 24 divided by 12 over 13, which is exactly negative 26. So my answer is correct. مش بس بقى, they will have an additional check كمان. You notice that there is a joint that we didn't use. There will be always that case. There is a joint that you didn't use. You can go to that joint and use it as a check. And that's one of the most beautiful things in this course. That in this course you will notice that you can always have a check. You always have something to check. But we forgot to ask ourselves the very important question that I taught you. You remember it?
Does it make sense?
Does it make sense? Why?
عشان الكويزز دي 22 ودول 24
Look at the big picture. That's positive 40, which means two tensions, tension force. And that's a compression force. And that's a compression force. Does that make sense? طيب, would it make sense to have it the opposite? To have this as a compression and this as a tension? Why? Why yes, why no?
لا عشان الكويت اللي بره اكبر فمش
As simple as that. This thing is like this, standing as if it's somebody who's tilted. صح? So if I get a load from my side like that, you see a minute. This leg is under tension or compression?
compression.
This leg. Tension. Right? That leg. Compression. لو واحد بيشد. Okay? So this is under compression, this is under tension.
But can't be switched.
If the load is split.
يعني لو
If the load comes this way, okay. This will be under compression and this will be under tension. You get it? طيب. بصوا بقى يا جماعة. This is one method. It's called the method of joints. Let's review the solution. Yes, we got the 40. Okay, we got the 10. We got the zero member. Well, alhamdulillah, we are good. So this is how we are drawing things here. Tamam? Right. This is a more thorough explanation of zero members. It's more or less the same explanation of zero members. Again, this is the case that we have, that you are having, here is drawing the local axis. Okay? You are having this thing on its own, so the component will be zero. The other case of a zero member is that a tip of a joint at the edge will be unloaded خالص. But here you are having two zero members in this case. Okay? يعني imagine that joint C here, for example, had nothing on it. Two zero members. صح? You get the point? No load. No zero. تمام. Okay? طيب. This is an example for showing you to get the zero members.
بس في حاجة يعني مستوعبة.
Yes.
يعني هو دلوقتي لو هو الستراكشر ده كان هيخلص من النص عشان الكويس تقيلة وبعدين حطينا الزيرو ممبر ده سبورت. هو الكويس يعني هو ازاي بيسبورت الستراكشر من غير ما
لا it's not the point that it was about to collapse. This zero member is doing what? It's not having a direct effect. It's not having a direct rule.
مش هو سبورت عشان لو الفورس اللي هي عند سي ده عند دي هيبقى بقى ساعتها مش
but
زيرو.
this is one of its functions.
بس ما ده يعني
ما
حاجة
خلاص
hypothetical، يعني الفويس اللي عند سي دي هتيجي عند دي ازاي؟
طب let's look at this case.
السؤال مختلف.
طب حاضر. Let's look at this case. This is a tower crane. This is a tower crane. Do you know winch? Okay. So that's a tower crane. A tower crane, in a tower crane typically the load is moving. The load is moving along the boom. This way.
فin this case مثلا هو
In this case one هنا but now it can change. It could go at A, it could go at C, it could go wherever. Okay. فطبعا at each of these load cases there will be zero members but there will be other members that have values.
ممكن المنبر يبقى زيرو في كيس تاني يبقى
Bravo.
فويس.
Exactly. Bravo. That's exactly what we are talking about here. Okay. تمام. طيب. So we are done for the day. تمام. You guys look really done. Okay.